Every single second, our planet is sending out invisible signals telling us its stories. Today, we're going to show you how we've built the tools to actually see them.
So think about this for a second. How on Earth can a satellite, hundreds of miles up in space, spot a tiny forest fire that's completely hidden by a huge, thick plume of smoke? I mean, it sounds like a superpower, right? But it's one we've actually built.
And the answer? Well, it's both incredibly simple and kind of profound. We've taught our machines to see using light that is completely invisible to our own eyes. And that has changed absolutely everything about how we understand our world. So let's start with the basics.
Our journey really begins with the secret language itself, light. Or, to be more accurate, the entire spectrum of electromagnetic energy.
Okay, so this is the electromagnetic spectrum. It's this massive range of energy, everything from super high-frequency gamma rays all the way down to these long, low-energy radio waves. And here's the fascinating part. Our eyes are almost completely blind to nearly all of it.
Just take a look at how small our little slice of reality actually is. See that tiny, tiny sliver? That's visible light. It contains every single color you've ever seen in your entire life. All the rest, those huge sections of infrared, microwave, and more, that makes up the invisible world our satellites are built to explore.
And here is the key idea. Every single thing on our planet, water, soil, a tree, a building, is constantly interacting with all this energy. It's reflecting some of it, it's absorbing others, and it's even emitting its own. Our satellites are essentially just eavesdropping on these silent conversations.
Okay, so if everything is constantly sending out signals, how do we tell them apart? Well, that's where things get really clever. We look for nature's unique fingerprints.
You see, every material has what's called a spectral signature. It's the unique pattern of how it reflects and absorbs different wavelengths of light. And just like your fingerprint is totally unique to you, a water molecule's spectral signature is unique to it. This is exactly how we can identify materials from space.
Let's take a healthy plant, for example. In the visible spectrum, the part we can see, its chlorophyll absorbs blue and red light to do its photosynthesis thing, but it strongly reflects green light. And that's why we see it as green. Simple enough, right? But that is where our human vision just stops.
But when a satellite sensor looks at that exact same plant in the near infrared, or NIR, it sees something completely different. Whoa, that plant reflects NIR energy incredibly strongly. To the sensor, it appears brilliantly bright, almost like it's glowing. This is a clear, unmistakable signal of healthy vegetation. And it's not just plants. Water is the complete opposite. It absorbs almost all NIR light, which makes it look black. And guess what? Soil, rocks, and snow, they all have their own unique patterns too. By recognizing all these different fingerprints, we can map the world in just astonishing detail.
So, since all these fingerprints appear all across the spectrum, we need different kinds of lenses to see them. Let's take a quick tour of the most important ones our satellites are using. First up is near-infrared, the one we just met. It is the absolute champion for monitoring plant life. Is a crop field healthy? Is a forest thriving? NIR gives us the answer, loud and clear. This lets farmers spot stressed crops weeks before we could ever see it with the naked eye, so they can apply water or fertilizer with surgical precision. It saves billions and helps protect the environment.
Next up, we've got shortwave infrared, or SWIR. Its superpower is detecting moisture. A dry, stressed plant looks completely different from a healthy one in this band. This makes SWIR absolutely essential for things like assessing drought conditions and mapping the burn scars left behind by wildfires. For firefighters, this means they can map a fire's true damage and direct their recovery efforts way more effectively.
Then there's thermal infrared. Now this lens is different. It doesn't see reflected sunlight. It sees emitted heat. And the crucial point here is that it works just as well at midnight as it does at noon. This is exactly how we spot that forest fire through the smoke. The intense heat signature just shines right through, day or night.
And finally, we get to the heavyweight champion, microwaves. Their really long wavelengths are the key. They can punch right through clouds, dust, and rain. This gives us true all-weather vision, which is absolutely critical for something like mapping a flood while a hurricane is still raging. For disaster response teams, this isn't just useful, it's life-saving. Okay, one last quick distinction. Most of these sensors we've talked about are passive, which means they're just listening for energy coming from the sun. But some, like radar, are active.
They actually send out their own pulse of energy, kind of like a camera's flash, and then they measure what bounces back. This lets them create super detailed 3D maps of the terrain below.
So we have the invisible light, we have the unique fingerprints, and we have our special lenses. Now let's put it all together and see how this whole process actually works from start to finish.
The process is actually pretty logical and beautiful. First, energy from the sun travels to Earth. Second, that energy interacts with the surface, a forest, an ocean, a city. Third, a satellite sensor detects the unique energy signature that bounces back. And finally, we process that data on the ground to create the maps and insights we can actually use.
So you see, it all comes down to choosing the right tool for the job. If you want to monitor crop health, you use the near-infrared lens, because healthy plants just shine brightly in that band. To find a hidden fire, you switch over to the thermal lens to see its incredible heat. And to track a flood during a huge storm, well, only the microwave lens can punch through those clouds and give you the full picture.
So why does all of this matter? What's the big deal?
Well, it's because seeing in these invisible languages gives us something like a planetary health checkup, but in real time. We can manage our resources more wisely, we can respond to disasters more effectively, and we can track the long-term changes that are happening to our home. We're not just guessing anymore, we are measuring.
We have developed this incredible ability to listen to the Earth's subtle, silent conversations, a dialogue that's happening constantly, whether we pay attention to it or not. So the only real question that remains is, with this newfound power to see the unseen, what are we going to ask our planet next?